Hello and welcome to Resistor Color Duo Part 2.
All right, let's look at how we can make this more functional by refactoring to use Lambda. And we'll start with the smallest thing that we can change and still keep our tests passing. And I think that is this function right here. So I'm actually going to call this one color values. I think that's more accurate. And then since these are more like the color names, I'll rename these to the color names. And then I'll create a new function here, and we'll call it color values. And this will map, it will map a color name to a color value. And so the name would be a string, and it will return a number. I believe that's accurate. So let's see, const color values. So it's a function that takes a color value, but it will actually be, with our new naming, a color name. And it will look that name up in the colors array, and it will return the index, which is a number. So this should still pass. Let's see. All right, we're still passing. And so we've abstracted this unit out of here, this function. And we can also use the Lambda index of as well. Import index of from Lambda. And since we're using the Lambda index of, we'll pass the data in as the last argument. Okay, so far so good. All right, so let's look at the next thing that we can change without breaking our tests. And so I think that the next thing that we can do is we can just go in order, and we can start with this map call right here. So we're going to import the Lambda map function, and so now we're not going to call map on the color names. We're actually going to pass the color names in as an argument to map right there. And then that will return an array which can be joined. So this should still work, and then sliced. And all of the result of all of that will be parsed to a number. Okay, so far so good. And yeah, so now we've replaced map, and the next thing we can replace is this join. So Lambda has a join as well, and it works. It looks like it works the same. The parameters are a separator and the elements. So the data is coming last. So the separator is the first argument. So it's basically the same, except we're not calling it as a method. We're calling it as a function. So we'll have to move this to be a function call right here. Join, and then the first argument will be the separator. So the first argument is the separator, followed by the data, the mapping, and then there might be a parenthesis issue here. Yeah, we don't need that parenthesis. Oh, we need to import join though. So let's get join. All right, so join the map, and it should be good. All right, so we're still passing, and we can kind of see the last. I kind of want to do something to make it fail, just to be sure that we are correct. So what happens if I just add like a comma here? That should break everything. Yeah, we're getting not a number, because a comma is not a number. So all right, so that's working. So let's do the last one. So slice. So this one is a little more tricky because I don't think Lambda has a slice. Oh, it does have a slice. And so we could use this slice, but actually, I think there's another way we can do it. And there's this function called take. And what this does, it returns the first n elements of the given list, string, or transducer. So they have some examples here. on a string, I guess that's the one that's most relevant to us. Take 3 and the string gives us the first 3 characters. So we can use this to get the first 2 characters of the number string. So I think we'll use this one instead of slice. So take, and I'll just remove slice. And so we'll call take. So I guess one kind of important thing to notice here is that we're nesting these function calls. And this is function composition. This is kind of the power of functional programming and that a library like Lambda gives us. We are taking the output of this join function and passing it as input to take. And we can say the number of characters that we want to take, and then the string. That should still work. All right. Yeah, so I think that's about all we can do without introducing a really powerful tool called pipe. So I'll import it first, and then we'll take a look at the documentation. And we can see at a high level what pipe does is it performs left to right function composition. The leftmost function may have any arity and the remaining functions must be unary, meaning they only take one argument, yeah. So, for example here, pipe, 3 functions, math.pow, r.negate, and r.inc. So the output of the first one will be the input of the next one, and so on, for as many functions as are in the pipeline. And the important thing to note is since it returns a function, this function that pipe returns is what we will pass our data to. So that's something to keep in mind. All right, so let's refactor this to using pipe. So I'll just call pipe right here. And I'll pass in the color names as the data to the function that pipe returns. And then now, so I'm going to get rid of this number call. And we're going to take each of these functions and put them in our pipeline. So the first one is the mapping function. And the next one is the join. And now since the pipeline is taking care of calling these functions with the data that we're passing in, we don't need to pass in the color names like this, since it will be passed in to each function in the pipeline, which we're just passing in as arguments with, if they have more than one argument, we're supplying those right here. And then the last argument, which is the data, will be passed in when it's called by pipe. All right, so join, and then the last one is take. We'll take 2. All right, so this will fail because we haven't updated, we haven't parsed it as a number. So if everything has gone well so far, we've tried to do this incrementally, we should be getting a string still. So let's see. All right, so we are getting the string as expected. And the last thing that we can do, it's going to be kind of anticlimactic, but basically, since number is a function, it's a constructor, the output of the last function call, take 2, will be passed to number, and that will give us the result we want. So that's it. Thanks for watching, and please go to the GitHub repository if you have any questions or would like to discuss different solutions to this problem. And talk to you next time.